great. We've had the break, and I'm pleased to report we've got some more wonderful questions that have come through on Facebook. Seems like today's the day for Facebook. But that's fine. If you don't feel like talking on the phone, that's perfectly okay. Again, I'm encouraging you to show your names. I see the people have started doing that. That's really good. So we can say thank you for the great question. Right, this next one is, again, very nice trick questions. I mean, they really are stunning. It says, prove that sine to the power 4x plus sine squared x cos squared x over 1 plus cos x is equal to 1 minus cos x. So I'm not going to worry about that too much. I'm going to say, okay, fine. Obviously, we start with a more complicated looking side, which is most certainly the left-hand side. So first of all, let's select a pen. That's generally a good idea. On the left-hand side, we can see, now you think to yourself, if you had x to the 4 plus x squared y squared over 1 plus y, for example, you would immediately see you have to take out the common factor. So what I always do is I say to my students, when you look at this, see sine to the s to the 4 plus s squared cos squared all over 1 plus cos x. So you know to take out the sine squared x, leaving you with sine squared x plus cos squared x all over 1 plus cos x. All right, that's great news. So now we look at it and we of course can immediately see over here we have one of our square identities. So we have sine squared x. This will become 1 over 1 plus cos x. All right, so far we haven't really got to the question, but it's fine. We've made it a lot smaller, a lot more neat, and easier to work with. So if we look over here, we want to get 1 minus cos x. So I can see that I can change a sine to a cos using that 1 minus cos squared x equals sine squared x. So in other words, a variety on that, or variable on that particular identity. So I can change that to 1 minus cos squared x. That 1 there doesn't really make a difference because 1 times 1 is itself. 1 times anything is itself. So it's cos x like that, and we can see we have the difference of 2 squares, which then becomes 1 minus cos x 1 plus cos x all over 1 plus cos x. And we can see that this now becomes just 1 minus cos x, which is exactly what this question asked me to show. And so it's equal to the right-hand side. All right, wonderful. So that was really nice and straightforward. Now it says, for what values of x is this identity not true? Now, the ways they can ask this is they can say, when is it not true? Or they can say, when is it undefined? Or when is it defined? Either way, we're going to do the same kind of process to actually come up with the answer. So let's have a look at it. What are they asking? Not true, so not happening. And so what we need to do is look at 3 main sections. The first thing is, are there any square roots there? No, they're not, because what do we know about a square root? We know a square root must be positive inside in order to find it. Otherwise, we're dealing with non-real answers, which we're not working with here. The second thing we would look at is, do we have any ratios that cause problems? Now, sine has got no problems. Cos has got no problems. What do I mean by that? Well, if I drew them, if I drew a basic sine curve, it would look like this. If I drew a basic cos curve, it would look like that. Notice there are no breaks in it. It's a continuous curve. But tan has problems. Every so often we get an asymptote, and at that asymptote, tan does not exist. Now, in this formula, there is no tan. Now, if there had been a tan, I always encourage my students to learn off by heart that whatever the angle is, in this case it's x, you would have said x may not equal 90 degrees plus k 180 degrees, k an element of integers. Finished, klar and kaput. Oops, that was a mistake. Let's put that down. So obviously now you can see that 90 plus k 180 would cover every single of these cases, because if I add on 180, I'd get the 270 problem and so on and so forth. And so I would know off by heart that if there was a tan anywhere here, that's what I would do. Now, there is no tan. So that means there's only the third option available to me, and the third option available to me is that I must work with a denominator not equaling 0. Because we know denominators equal to 0 means that the fraction is undefined. And if the fraction is undefined, obviously it's not true. So we know that the only problem in this particular question is that we must look at the denominator not equal to 0. So here we have it. Now they said to me, when is it not true? So it's not true when 1 plus cos x equals 0. Okay, identity not true. Okay, so how do we know solve this? We go cos x equals minus 1. And then the easiest way to solve this is to think of the graph of a cos function. It would look like this. And we know it would equal negative 1 over here at 180 degrees. So we could say x is 180 degrees plus k 360, because the period of a cos graph is 360, k an element of z. Now I can hear people groaning because on the Facebook question page came a whole lot of questions around general solution. So I will also show you how to use the general solution here. But to be honest with you, I think that is the easiest way to do it, especially something like this. It would only be worth about 2 marks or something like that. But if you wanted to, we could go the reduction form, not the reduction formula, the general solution. Now, it's up to you. Your teachers either have or have not taught you to work with a negative. I personally like to work with a negative. For me, it makes it easier. So I'll show you the one way of doing it now. And then the next question we do, I'll show you the other way and the way I've just shown you as well. What I do with general solutions, I keep on calling them special angles, is I remember 3 things. I know that if sine x equals a would have to be an element of minus 1 to 1. And then I know that x can be found using our shift button for sine plus k 360, or x is equal to, and I think I should have put it down here rather for space, x is equal to 180 minus shift sine a plus k 360. Okay, and then for cos, same story again. My a must be an element of minus 1 to 1. And so if I look at that, I would say x equals plus or minus cos to the negative 1 of a, or shift cos if you like, plus k 360. And of course, I've been a bit naughty. I've forgotten to write this in every time, but you're going to be well behaved. Again, remember that if you don't do that, they will penalize you certainly on one of the questions for not doing it. But I doubt they would penalize you every time you do it. But you never know, so try not to do it if you can possibly help it. Now, if tan x equals a is an element of any single number. Now, we'll explain why these become so in a moment. And of course, x is equal to shift tan a plus k 180, because the periodicity of a tan graph is 180, k an element of z being integers. Now, the reason is quite simple. If we look at the sine curve over here, and let's just draw in a little bit more over here so we get the look going. And I'm saying to you, solve for it equal to some number. Oh, that was not a clever move at all. You agree with me, the first answer we get would lie in the first quadrant, because that's between 0 and 90. The second one would lie in the second quad, which is 90 to 180. If I had a positive value, but if I had a negative value, it would throw down here. But that's not important. But we know that exactly 360 degrees away would be another solution, and 360 degrees away yet another solution, and on this side as well. So that's where that's coming from. Oh, these axes of mine are beautiful. Okay, so this is your cos curve, and again, not the greatest curve in town. And we are putting in a solution here. Notice that there is a symmetry over the y-axis. So there's a plus and minus, so that's why you get this plus and minus cos whatever. All right, and then the last one was the tan one, and if you look at a tan curve, it looks like this, etc., with our little asymptotes going down here. And again, if I was looking for the solution here, you can see there's the one, and 180 degrees away is yet another one, and so on and so forth. So that's where these formulas are coming from, and if you've been shown this way, I think your teacher's done you a favor, because it makes it so easy. But however, I will show you the other way with a reference angle on another question that's come up, and I'll show you how easy it is to do it with this. So all I would do now is I would go back to this question, and I'd say, well, that means that x is equal to plus or minus. I would pull my calculator up, and all I would do is I would go second function cos, open the brackets, I want to go negative 1, close the brackets, and I press the equals, and I see I get 180 degrees immediately, which is what I know I was going to get. All right, that was not clever at all. 180 degrees plus K360. But you'll say to me, but hang on a moment, you only had the positive. Well, obviously, if that's 180, over here, we would have got the negative 180. So it makes perfect sense that that 1 would cater for all of them. So if you gave it like that or you gave it like that, I don't believe you would lose any marks, so it would be absolutely fine. All right, now what I'm going to do is I'm going to start the next question, but I suspect we can only get part of the way before we need to ad break. All right, maybe we should take the ad break first again. Let's take the ad break first, and then we'll come back to the question. It's a lovely question on 3D tricks, so come back and join us. Remember to contact us on 0861 058 262 or on www.facebook.com/learn extra. We'll see you after the break. Thank you.